Welcome back to the runtime error once again. In this video, we will be discussing the implementation part of the single linked list. I hope you have watched my first video so that you can come to know that the basics of linked list, why do we need a linked list, and how to create the node. If you have missed the video, I fully recommend you to watch my first video. So now we will start the implementation part of the linked list. Here we will be discussing inserting node at start and insert the node at end. So these two things we will be implementing in the single linked list. But before we implement the single linked list, I want to tell something more about how the address is stored, where to store it, how to do it. If you ask me what is linked list, I won't be calling linked list as any kind of data structure. I would be simply calling it as a diagrammatic data structure, because if you're really clear about diagrammatic way, then you can easily get the linked list. So let's get started. So what I want to say is, I want to teach you first how the addresses are stored. So the first thing is, I'm going to create the node. So I will be instruct node. It will be of int data type, a data that I need to store. And again, as I told you in the first video, that we will be storing the address of a next node which is of node data type. So what I will be doing is, now I will be using, so say for example node, I will be calling it as a new node equals to new node. Now this is a keyword, as I told you in the first video, which allocate space during runtime. Now the question is, what if the space is not available? Now I will tell you, say for example, if I'm looking for a space 100 MB, but 100 MB of space is not available. So what it will do? So new basically returns two type of things. One, space not present and space available. So whenever the space is not present, it simply returns a null. And whenever the space is available, it simply returns the address that is starting address of that space. Say for example, this is my main memory and I have got this much space. Now starting address of this space is, say for example 1000, so it simply returns 1000. So where I'm storing this address, or where I'm storing the value returned by the new, so store that value, I'm using the data type that is called a new node. I hope so you got me. If new node contains null, which means the space is not allocated. If it contains any kind of data apart from null, it means that it has the address of that allocated space. I hope so you got me. Say for example, I have created a node, new node. Now what will happen? Now I got the address is 100, so this address will be stored in a variable called as a new node, so it will be storing the 1000. Now this 1000 is an address of a next node, this 1000 is address of next node. So I hope so you got me what the new basically returns. If the new is returning me null, it means the space is not allocated. If my new is not returning null, which means it is returning the address of that allocated space. I hope so you got me. Now let's create a node first. Now I will be creating the node, but before creating the node, what I need to maintain is, I need to maintain a special pointer which is called as a head, or you can simply call it as a start. Now the question comes, why do we need these two pointers? It simply needs so that we can come to know that the starting point of my linked list. Say for example, if I have my linked list like this, and I don't know the starting point. and I don't know the starting point. Now the question comes, if I ask you to fetch the data stored in the linked list, say for example, if I have got 1, 2, 3, 4, it contains 10, 20, 30 and 40. These are the addresses, and this contains a null which simply says that end of my linked list. Now say for example, it contains 20, it contains 30, it contains 40. Now if I ask you, I need to fetch the 3. Now the question comes, how you can fetch it, because you don't know where the linked list is starting, whether my linked list is starting from this node or this node or this node. I don't know. This is the reason why we need to maintain this spatial kind of a pointer, just to know that the starting point of my linked list, so that whenever I need to fetch any data present inside the linked list, I can easily fetch that value. So what I will do is, whenever I create my first node, I will also keep one separate pointer that will be pointing to my first node, so that I can easily come to know that, okay, this is my starting point of my linked list. I can go from this to its right side. I hope so you got me. Why do we need a special pointer called as a head, or you can call it as a start? So how we will create it? So we will do again, look it from scratch. Now again I will create a struct node. It will be storing data called as data. It will be storing the address of a next node. It will be having the constructor. Now I am defining the constructor as I shown you in the first video. So it will contain data equals to num, and my next is equals to null. So this is the structure of a linked list. I hope so you know this very well, and this is the most important part throughout the linked list chapter. Now I have created, say for example, one node, so I will be using as node. Sorry, I will change my color. So I have created called as node. Now say for example, a new node will be the variable name I will be using equals to new node, and the value I want to show is, say for example, 7. So it has created a node, okay, 7. Here I have the null, here I have 7, and say for example its address is 1000. Now what I will do is, since this is my first node, I will also keep one extra pointer which name is called as a head, or you can call it as start as well. There is no any issue. So this head will be holding the address of my first node, and my first node is 1000, so it will contain 1000. So this will be pointing to this node. Now say for example, I have created one more node, new node equals to new node, say for example as 9. Now I have created a node. It contains a null, since it is present in our constructor, because any value I am passing it is assigning to the data, and the next itself is getting null. So this will be getting null, and here I will be storing as 9. Say for example its address is 700. Now again what I will do is, since it is my starting node, so again I will keep one extra pointer that is called as head, and head will be pointing to new node that is called as 700. So I hope so you got this, so that it can point into this. Now the question comes, how can my head point to new node? So what I will simply do is, once I have created this new node, after this line, what I will write is, I will simply write is head is equals to new node. Now the question comes, what does a new holds? New simply holds the address. Which is basically written by our new keyword. Now in this my new node contains a value called as 1000. So what I'm doing is, I'm assigning that 1000 value to my head. So my head will be containing the 1000. In this, my new node contains address called as 700, which will be assigning it to my head. So it will be as 700. So I hope so how we are assigning the value or the address of that new node to the head. I hope so you got this. Now let's create the linked list. Now what I will do is I'm maintaining a spatial node just to keep a track of my first node. So that name of that spatial node will be head itself, which is initially at null. What does it means? It means my initially my linked list is empty. I don't have any kind of linked list. Now again, what I will do is, see, I will create a node called as struct node. Say for example, new node equals to new node 7. Just for the sake of information, that is, this keyword, that is struct keyword, is optional, which means even if you don't write the struct, it's still fine. It's still fine. Even if you write as a node, it still works. It still works. Now, say for example, I have created a node which is of new node, and what I will do is since if my head is null, if my head is equals to null, which means my initially my linked list is empty. Initially my linked list is empty. So what I will simply do is I will assign as head is equals to new node. Means what has happened here? I have created a node. Say for example, I have value as 7. Here it contains a null, and say for example the address of this node is 300. Okay, now my head is null. Okay, I have declared here my head is null. Since this condition gets true, so what I am doing is I am assigning the value from the new node to the head. So simply head will be containing the value called as 300. So it will be pointing to this side. Now suppose again I am creating the new node. Node star new node equals to new node, say for example as 3. Now the question comes, my head is not null, which means I have already started with my linked list. Okay, I have already started with my linked list. But the point is I want to insert that node before this node. What did I did first? I said to my linked list that this is my first node. So I store the address of this node in my head so that whenever I want to fetch the data, I can come to know that this is my starting node. But what I'm saying is I want to store this node. Say for example, this node is 3, this is null, and the address is say for example 700. I want to store this node before the previous node, which means I want to store like this. 7, this is null, this contains 300, this should contain 300, and this will be pointing to this, and my head will be pointing to this. So head will be contain 700. How will it work? Just think from the diagrammatic point of view. Okay, what I will do is, okay, this is my head, which contains a value 7, which is at null. This is pointing to this. Say for example its address is 100, so this will be pointing 100 over here. Now I want to insert a data before this node. Before this node. So what I will do is, say for example I got 3, here is null, and my address is 300. Now what I will do is just observe carefully. Now the value of this node is 300 since its address, so new node. Now can I say new node of next? What is next? This is data, this is next, and this is new node. So new node has two compartments, one is called as data and one is called as next. So can I say new node of next, which means I went on to here, is equals to head. Now the new node of next, what is this? This is next, right? So this is my next. So what I'm doing is new node of next is head. Now what is the value of head? The value of head is 100. So what it will contain? So it will contain 100. But the point is the 100 is address of which node? 100 is address of this node. So this will be pointing to this. I hope so you got me. new node contains two parts. This is called as the data part, this is called as the next part, and this whole is called as a new node. So what I'm simply doing is new node of next, new node of next, new node of this. If I write as new node of data, then which means I'm moving at here, I'm moving at here. I hope so you got me, I hope so you got me. So simply what is happening is new node of next, I did head, which means it contains 100, which is the address of this node, so it will be pointing to this. Now the question comes, okay, my new node is pointing to this node, but my head is still pointing to my this node, but this node as my become as my first node, so head should be pointing to this node, head should be pointing to this node. So what I will do is, I will simply do is head equals to new node, head equals to my new node, so this will get vanished and my head will be pointing to this, so here it will come as 300. So I hope so you got me how we are trying to insert a node at the start, So we will write this code once again, say for example I'm declaring the function void insert at start. Okay, so now what I will be doing, I will first create a node, say for example node new node equals to new node, and at any data, say for example we are taking that data as a parameter from the function int num, so I will be passing here as num. Now what I will do is first I will check if my head is null, if my head is equals to null, which means my initially is empty linked list, right? So what I will do is I will simply act as head equals to new node, right? Else which means my linked list initially has at least one node, say for example here I have at least one node, this is a null, this address is 100, value is 7, and my head is pointing to this location that is called as 100. Now I want to store the new node, of 3 whose address is 200, initially it's null. So what I will do is, I will simply do is new node of next equals to head, and head equals to new node. I hope so you got me. So what is happening at here, this contains an empty linked list, and this contains this part contains at least one node. So what I'm doing is I want to insert this node before this node. So what I'm doing is I'm doing new node of next, so this is the whole my new node. So new node of next, which means this part, right? So what I'm doing is new node of next is equal to head, So what is head? So head contains 100, so 100 will be stored at here, So how it look like? It will simply look like it will contains 100, so it will be pointing to this node. Now what does this second line mean is head equal to new node, and the value of my new node is 200. So what will happen is it will be, so head will contain as 200. Now so this bond gets break and it will simply point to this. So how does my linked list looks like now? So my first node contains as 3, which contains address as 100, whose address is 200, and my last node contains a 7, which contains null, which simply indicates my end of my linked list, whose address is my 100, and my head is pointing to my this node, which is a 200. So I hope so you understand insert the node at start. I hope so you understand. It's lot more easier. Now say for example one more node comes that I want to store. So it becomes as, say for example, its address is 300, value is 12, and initially it's null, right? So again I will check, is head is null? Okay, my head is not null. Then I comes at else part. So new node of next. So new node of next becomes head. So what is the value of head? So what is the value of head? Value of head is 200. So it will simply becomes 200. And then what will happen? So head equals to new node. So what will be the head? So head contains a new node which is 300. So can I say this will become as, so it becomes 12. It will be holding the address of 200, which is the address of next node, 100. So it will be holding the address of next node, that is 7, and this is null. The value is 300, 200, and 100. These are the address of that particular node. So I hope so you understand to insert the value at end. Sorry, to insert the value at start. This is lot more easier. If you go through diagrammatic point of view, the linked list is lot more easier. Now we will look at how we can insert the data at end of the linked list. Say for example, I have the linked list. Say for example, if I have the linked list like 7, 3, and 9, and this is end of my linked list. So this is my content head. Head will be containing the address of 100. This is of 110. This address is 20. So now I want to insert a node. At last, means I want to insert over here. So I will be this will be pointing to this. I want to insert over here. How can I do it? Just we need to think from diagrammatic point of view. I want to think from diagrammatic point of view. Say for example, initially I don't have any element, so I will be having the first node. Okay, I have my head will be pointing to this. This is null. Say for example 7 and 10. Okay, now I want to insert one more element over here. Okay, since I have my single node, simply what can I do is, can I say head of next? Head is pointing to this whole node. Again we know that this node contains the data and it contains the address, which is next. So can I say head of next equals to new node. So say for example new node is 700, so it will be acting as 700. So it will be pointing to this. So value is 12 and this is null. Now again my new node comes in. Okay, it was address is 20. This is null and this is 8. Now I want to store. Now can I say head of next? Is equal to new node? Absolutely no, because the head of next is this part. But I want to store the address of this node into this section. So can I say head of next equals to new node is absolutely wrong way to insert element at end. Right? Absolutely the wrong way, because if I have the one node, then it's okay. But if I have the two nodes, or we can say that more than one node, then the value of this statements is absolutely useless, because the point is we cannot say head of next equals to new node, because the head of next is pointing to this node. If I try to do this thing, then what will happen? The head of next will be pointing to this node, and this junction will get break. So this is absolutely the hell thing. So can we do something that, can we store one more pointer, so that say for example at here, and what I will do is, if any node I insert, I will put that pointer on that node. Say for example now pointer was at here, so I inserted the new node, so I will move this pointer over here, so it becomes at here. Now since my pointer is present at here, so simply what I will do is, say for example pointer name is temp. So what I will do is, if my temp of next equals to new node, can I say this thing? My temp of next equals to new node. So new node is 20, so it will be containing 20 and will be pointing to this now. Can I say? Absolutely yes. So what I will do is, to insert a node at the end, I will try a special one more pointer, say for example called as a tail, which will be pointing at my last node, so that it becomes a lot more easier while inserting a node at end. Let's check once again. Now say for example my initially head is equal to null, right? So I got one node whose address is 10 and contains element as 7, and this is initially null. Okay, now at the same time I have used a pointer called as tail. Okay, tail is pointing here. Now I come one more node whose address is 20, initially it contains null and value is 8. So what I do is, can I say tail of next, that is this part, can I say tail of next, that is this part, is equals to new node, which means it contains addresses 20, that is pointing to this part. Now again what I will do is, I will simply upgrade my tail, which will be pointing at here. Now say for example again I want to insert an element whose address is 30, initially it's null and it contains value is 80. So can I say tail of next, can I say tail of next equals to new node. So new node address is 30, so what will happen is here we will be having a 30, so this will be pointing to this. Now since I need to upgrade this tail pointer from this location to this part, so what I will do is I will simply do tail equals to new node, just like what we did here. Head equals to new node, just to point my head to my first node. I hope so you got me how I'm upgrading the tail pointer so that it becomes easier to store the element at my last. I hope so this makes sense. Now let's write a code for it. I will be calling a function void insert at end. It contains a data as num. So what I will do is I will create a node, say for example name as new node equals to new node num, right? Again I will check if my head is null or not, because if my head is null and I'm trying to insert that element as end, where is my end? If there is no starting of linked list, how can you say that there is end of the linked list? Absolutely false. So again what I will do is I will simply put it as head equals to new node, and at the same time what I will do is I will keep one extra pointer, that is tail, so it will be also pointing to new node, right? So what is happening, so I created my first node, I will change my color. I will be creating my first node whose address is 30, the element is 9 and this is null. So what I am doing is I am keeping the head which contains a 30 will be pointing to this, and also I am keeping the tail which is also pointing to this. I hope so you got me. Else what I will do is, if my head is not null, which means my linked list contains at least one element, otherwise what I will do is I will simply upgrade it as tail of next equals to new node, and what I will do is again I will upgrade my tail, so tail equals to new node. So this is the most simplest insert at end code. So let's check how it works. Initially my head is null. Okay, here I will declare a pointer that is tail is present and null. Okay, I hope so you got this. I have declared the special pointer tail, which is of node type itself, because we are going to store the address of that node, so we need a pointer which is of the same data type. Initially it has null. So what is doing, so I have created my first node, say for example value is 8, now its address is 10, so head is equals to null. Okay, this condition gets satisfied, therefore head it becomes equals to new node, that is this will be pointing to this, and again my tail also pointing to this. Now suppose I have created one more node whose address is 20, it has null, and say for example I have the value as 7. Now what I will do is Is my head equals to null? Absolutely no, because I have one element. This condition gets false. I come to else part. So I will do tail of next. I will do as tail of next. This is my tail. This is my next. So what it will be? Tail of next. Tail of next is equal to new node. That is this part. Tail of next is equal to new node. That is this part. 20 part. So 20 part. So what I will do is tail of next. So what is tail of next equals to new node? So what is the value of new node is 20. So here it will be stored as 20. This will be pointing at here. And again this part tail equals to new node. So value of new node is 20. So tail will be pointing at here. Now say for example one more node comes, which is at initially at nulls. Address is 40 and the value is 18. Now check. Is my head equals to null? Absolutely not. So I comes to the else part. So tail of next. So this is the tail. This is the next equals to this part. This is the tail. This is the next of that tail, and this is the part that I need to store. So what I will simply do is tail of next is equal to new node, that is comes at 40. So it will be pointing to this node, and the tail will be shifted to the new node that is over here. So I hope so you got the insert at end. So this is from this video, that the most important part that I have discussed is how to implement the linked list, and I hope so I tried my best so that you can understand. You can see both the code of insert at start and insert at end. So let me erase this so that you can understand in a better way. Okay, so this is insert at start, that is first code that we saw. If my head is null, simply it says that my linked list is empty, so I have simply assigned the address of new node to the head. If this condition is false, then what I did is I simply new node of next, that is this is the new node, and new node of next I have inserted the value of head so that it should point to this node, and again I updated my head so that it can point to this node. So this way we utilize the insert at start, that we want to insert a node before the previous node. Say for example my previous node was my 7, so I want to insert a node 3 before 7. So this was about insert at start. Then we come across the insert at end thing. So it is the same code to insert at start. So what special thing we did is we kept a special pointer called as a tail, so that it becomes a lot more easier updating the previous node. So thanks for watching. Do subscribe the channel. Till then, have a happy coding.